Hi everyone, welcome back to our channel. In this video we are going to learn about nomenclature of heterocyclic compounds. But before that we should understand the definition of the heterocyclic compounds and also carbocyclic compounds. Now first we can start with carbocyclic compounds definition. See here, carbocyclic compounds is a cyclic organic compound containing all carbon atoms in a ring formation. If in a cyclic organic compound all the atoms present are carbon and hydrogen only, means that is carbocyclic compounds. But whereas if we see heterocyclic compounds definition means if at least one atom other than carbon forms a part of a ring structure, then it is called as heterocyclic compound. See, here is a carbon and here is also carbon. In the first atom is oxygen, second one is carbon here, we know that, and third one is carbon, fourth one is carbon, and fifth one is also carbon. Now one of the carbon, in the place of carbon, what is replaced here? Oxygen is replaced. So that type of compounds which are present other than carbon, which forms a ring structure, these are called as heterocyclic compounds. In the carbocyclic compounds, only carbon containing atoms are only present and they are involved in the ring formation. But in the heterocyclic compounds, an atom other than carbon is present. See, let's see the definition. If at least one atom other than carbon forms a part of a ring structure, it is a ring structure. Here is the carbons. Instead of carbon, here is the oxygen. If at least one present means also it is called as heterocyclic compounds. Now it is named as furan, and here you can see the carbon is replaced by sulfur. It is called as thiophene. These are the examples of the heterocyclic compounds. Now coming to the definition, the very correct definition of this heterocyclic compounds is that it is a cyclic organic compound. We know that these are the cyclic organic compounds, or these cyclic compounds whose ring consists beside carbon one or more atoms of other elements. The non-carbon atoms in such a ring are referred to as heteroatoms. The non-carbon atoms, you may take oxygen, nitrogen, sulfur, like that. These are the heteroatoms. The atoms other than carbon and hydrogen are called as heteroatoms. The most common heteroatoms are nitrogen, sulfur and oxygen. This is the correct definition of this heterocyclic compounds. It should form a cyclic ring structure, and other than beside carbon there are one or more other elements or other atoms which are involved in the formation of a ring. These are called as heteroatoms. The most common heteroatoms are nitrogen, sulfur and oxygen. Okay, now coming to our topic, that is nomenclature of heterocyclic compounds. The nomenclature of heterocyclic compounds is of three types. We shall discuss all these three types in our today's video. Now, the nomenclature of heterocyclic compounds are divided into three types. The three systems for naming heterocyclic compounds are: the first one is the common nomenclature, and the second one is the replacement method, and the third one is Hantzsch-Widman nomenclature. This is the IUPAC or systematic nomenclature, whereas this common nomenclature and the replacement method or the non-systematic nomenclature of these heterocyclic compounds. Now coming with the common nomenclature. Now let's study this common nomenclature. In the common nomenclature, the basic point is no structural information is involved in the common nomenclature. This common nomenclature will not give any structural information of the compound, but it is still widely used. Okay. The second point is each compound is given the corresponding trivial names. That means non-systematic names are given to these compounds. How these names originated means they are originated from the compound occurrence, its first preparation or its special properties. They may originated from their occurrences, first preparations or special properties. These are the common nomenclature. This is about the common nomenclature. Now let's see some of the common nomenclature in this heterocyclic compounds. Now let's see the example of this. First one is 5-membered heterocycles with one or two heteroatoms. Here it is a 5-membered ring. It is a 1, 2, 3, 4, 5. Total consists of 5-membered heterocycles. If one of the carbon is replaced by oxygen, we will call it as furon. Whereas the carbon is replaced by sulfur, means it is called as thiophene. Okay. Now let's say common azoles. Aza means if a nitrogen group is present in heterocyclic compounds, we will call it as aza. Let's discuss about these in our. Now let's see about these common azoles. These are let's study about 5-membered aromatic nitrogen heterocycles. Okay, here it is a pyrrole. 5-membered ring. It is replaced by one of the carbon is replaced by nitrogen. It is called as pyrrole. Here it is imidazole. Here NH is present and here the nitrogen is present. Okay, here is a pyrazole. See the difference between the two structures. It is pyrazole and it is isoxazole and it is oxazole and it is thiazole. These are the trivial names or the common nomenclature of these heterocyclic compounds. They are given these names by their origin or their occurrence or their special properties. Now coming to the 6-membered heterocyclics, one with 1 or 2 heteroatoms, it is called as pyridine, it is pyridazine, it is pyrimidine, it is DNA or RNA basis. We already know that these are pyrimidines, and next one is pyrazine. Okay, it is pyridine, that is the 6-membered ring. One of the carbon is replaced by nitrogen. It is called as pyridine. It is pyridazine. When 2 nitrogens are present, here you can see the difference between this one and this one, that is pyridazine and pyrimidine. And next one is pyrazine. These are differentiated on the basis of their nitrogen positions. Next, trivial names for the fused heterocycles. Here common ring fused azoles. Okay, it is a 6-membered ring and it is also a 6-membered ring. Here one of the carbon is replaced by the nitrogen. It is called as indole, and next you can see the position of the nitrogen is shifted, so it is called as isoindole and it is called as indazole. Okay, just compare the positions of nitrogens with one another, you can easily get it. It is called as indazole. It is purine. We already know the DNA and RNA bases of purine and pyrimidines. And here you can see it is a purine and it is quinoline. These are the quinolines. These are fused heterocycles. And this indole, isoindole, these are the trivial names. Now coming to the saturated heterocycles, they don't contain any double bonds. Okay, it is pyrrolidine, and the second one is piperidine and piperazine and morpholine. These are the examples of these saturated heterocycles. Here we are studying about the common nomenclature, that is non-systematic nomenclature. These names are originated by their occurrences: pyrrolidine, piperidine, piperazine and morpholine. And the second type of nomenclature is replacement nomenclature. Now we have studied about the common nomenclature. Now coming to the replacement nomenclature. Let's see the definition of this. Heterocyclic name is composed of corresponding carbocycles name and an elemental prefix for the heteroatom is introduced if more than one heteroatom is present. For naming the replacement nomenclature, the carbocycle's name is also involved. The carbocycle means it is a ring structure. It is composed of only carbon atoms and hydrogen. Okay, here and an elemental prefix for the heteroatom is introduced. Here elemental prefixes for the heteroatoms are like this. For atom oxygen, we use the prefix oxa. Okay, oxa. It must end with A, and for this Se, that is selenium, we will call it as selena. Okay, for the sulfur we will call it as thia, and for the nitrogen we will call it as aza, and for the phosphorus, phosphor. And for the silicon we will call it as sila, and for the germanium we will call it as zerma. These are the atoms and these are the prefixes that are used in the for the naming of this heterocyclic compounds in the nomenclature. Now see, for the oxygen we will call it as oxa, for the selenium we will call it as selena, and for the sulfur we will call it as thia, and for the nitrogen aza, phosphorus, phosphor, silicon, sila, germanium, germa. See, priority order of this heterocyclic compounds, the highest priority is oxygen, and the second one is sulfur, and the next one is nitrogen, and the next one is phosphorus, and next one is silicon. These are the priority orders for the atoms in the heterocyclic compounds. Okay, these are the prefixes, and this priority order is very important. You must remember these things. First one is oxygen, and next is sulfur, next is nitrogen, phosphorus, and silicon. Now let's see the example of this replacement nomenclature. We already know that it is a carbocycle. Why? Because all the carbon atoms are present. Here is a carbon, 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 carbon. We know that in the benzene 6 carbon atoms are present. So the other atoms like oxygen, sulfur are not present along with the benzene. So it is called as carbocyclic compound. Here in the replacement nomenclature we have seen the definition that with the heterocycles name, carbocycles name is also involved. See, we already know that here nitrogen is called as aza. The prefix aza is used for the nitrogen. See, here the carbon is replaced by nitrogen, and here is the carbon is replaced by nitrogen. So how many nitrogens are present? That is 2 nitrogens are present. Okay. Here let's name it as 1, 2, 3, 4, 5, 6. It is 1, 4. 1, 4. How many nitrogens? That is 2. 2 means di. Okay. 2 means di. 3 means tri, like that. 2 nitrogens are present. So di aza means 2 nitrogens are present. So di aza carbocycle is benzene. Okay. First, according to this nomenclature, prefixes for the heteroatom plus, next here the prefixes for the heteroatom is aza. Okay, next what is involved? Carbocycle's name, that is benzene is a carbocycle, so carbocycle's name is used in the replacement nomenclature. See, is a benzene, it is a carbon cycle. First prefix for the heteroatom, that is we know that here 1,4 di aza is present. That means 2 nitrogens are present. Here nitrogens are called as aza, and they are present in the 1 and 4th position, so they are called as diaza, and the carbocycle is benzene. Like this. Next, let's see second example here. Now coming to the second example, we already know that it is cyclopentadiene. This structure is cyclopentadiene when one of the carbon is replaced by the oxygen. Here we know that oxygen is called as oxa in the heterocyclic nomenclature. See, here the oxygen is oxa. Okay, first we should use the prefixes for the heteroatoms, as I have given the formula here. Here the prefixes for the heteroatom is oxa. Okay, here oxygen is present, that's why it is called as oxa. And next, the carbocycle's name is cyclopentadiene. Now this is done and this is done. And now the third one. Here it is also cyclopentadiene. Here, see here. Here one of the carbon is replaced by oxygen and one of the carbon is replaced by nitrogen. Here I have given the numbering. The numbering is given in the order that according to the priority. We know that priority, I have already shown you the priority. The important priority order is like that. We already know that oxygen, sulfur, nitrogen, phosphorus, silicon. Now, here the oxygen is given the first preference, so it is numbered as 1, okay. By following the priority order, we should name these compounds, okay. Here the oxygen is given the numbering 1. Why? Because here it is highest in the priority order, so oxygen is given 1, and next 2, next comes the 3, okay. First numbering is given to the oxygen. Why? Because it is having higher priority for naming, so oxygen. And next here the carbon is getting second naming, and the nitrogen now is getting third one, okay. First, in the first position we are having oxygen, that means oxa, okay. And in the third position we are having aza, okay. In the first position we are having oxa, and in the third position we are having nitrogen, it is called as aza. And next one is cyclopentadiene. We already know that prefixes for the heteroatoms. The prefixes are oxa. There are two heteroatoms, so we should give, that is two different heteroatoms, so that's why we are giving the numbering. And for the same heteroatoms also we should give the numbering. So there are more than one heteroatom, so we are giving the numbering. Here oxygen is in the position 1, so it is 1 oxa, and it is 3 aza cyclopenta 2,4-diene. It is cyclopentadiene, it is 1 oxa 3 aza cyclopentadiene. You should name it as like this, 1 oxa 3 aza cyclopentadiene. It's enough. Here this is also completed. Here 2,4-diene means here double bond is present at the 2 and 4th position, so diene, okay. And now fourth example is cyclopropane. It is cyclopropane. The carbocycle name is cyclopropane. When one of the carbon is replaced by the oxygen, see what it is called as, it is oxacyclopropane. It is a cyclopropane. When one of the carbon is replaced by oxygen, it is called as oxacyclopropane. Now it is cyclopropene. Why? Because a double bond is present between the two carbon atoms, so it is called as cyclopropene, okay. It is ene and it is ane, okay. It is cyclopropene. Here when one of the carbon is replaced by oxygen and one of the carbon is replaced by nitrogen, here see, here this carbon is replaced by oxygen and this carbon is replaced by nitrogen. Now let's give the numbering. We already know that the order for this. Let's name it as 1 and let's name it as 2, okay. 1 oxa, and in the second position we are having aza, so it is cyclopropene, okay, like this. 1 oxa, second one is aza, cyclopropene. Now this is also completed. Now coming to the next one. Again we are given the, now sixth one, again we are given cyclopentadiene. Here one of the carbon is replaced by sulfur and one of the carbon is replaced by nitrogen. See, this carbon is replaced by sulfur and this carbon is replaced by nitrogen. Now order of priority is like this. We know that this sulfur, this is important. Here sulfur is having higher priority, so it is given the numbering 1, whereas the nitrogen comes the second after the sulfur, so it is 1 and it is second, okay. Here it is in the first position we are having sulfur, so we'll call it as thia, okay. And in the second position we are having nitrogen, so we'll call it as aza. And the carbocycle's name is cyclopentadiene. Again same, here prefixes for the heteroatoms. Here the prefixes are thia and aza, and the carbocycle's name is cyclopentadiene. Okay, now let's see the seventh one. We are taking more and more examples to make you understand better. So it is cyclohexane. This one is cyclohexane. We already know that it is very simple. It is cyclohexane. Here one of the carbon is replaced by nitrogen and one of the carbon is replaced by oxygen. Now let's try to name it. Okay. Here according to this priority order, what is given the first name, that is numbering. First highest numbering is highest priority for the oxygen. So it is 1. Okay. And here coming to second, third, fourth. Now the nitrogen has become fourth one. So the numbering on the nitrogen is 4. Okay. If we come on this side also, we'll get 4 only. So 1, 2, 3, 4. Okay. 5, 6. Now try to name it. First what we should do? First name these prefixes according to their priority. The first priority is given to the oxygen. So it is 1 oxa. And in the fourth position we are having aza. So and cyclohexane. Again the prefixes for the heteroatoms is utilized, and also next followed by carbocycles name. Okay. It is 1 oxa, 4 aza, cyclohexane. And 8th one is here coming to the 8th one. Now we already know that it is naphthalene. Now try to name this one. Here only nitrogen is present. Nitrogen is called as aza in this nomenclature. So it is azanaphthalene. That's it. These are the 8 examples. Complete it. Azanaphthalene. These are the 8 examples of this replacement nomenclature. I think you have understood it very well. Now coming to the very important nomenclature, that is IUPAC nomenclature, systematic nomenclature, that is Hantzsch-Widman nomenclature. That is very important and also difficult when compared to these two. But before that, if you haven't subscribed to our channel, please subscribe to our channel. Let's start with this IUPAC nomenclature now. Now Hantzsch-Widman nomenclature. Here this heterocyclic nomenclature is based on the type of heteroatom. It is very easy. Please once understand it. The heteroatoms are oxygen, sulfur, nitrogen like this. And the second one is ring size. And the third one is nature of the ring. Based on these properties, the nomenclature of these heterocyclic compounds is carried out. So heterocyclic nomenclature is based on these: type of heteroatom is present, and also ring size, and also nature of the ring. Here nature of the ring includes saturated or unsaturated. Saturated means there are no double bonds or triple bonds, whereas unsaturated means there is presence of double bonds and also triple bonds. By considering these features, we are naming these Widman, Hantzsch-Widman and nomenclature. This nomenclature is given by German chemist Arthur Hantzsch and Oskar Widman. So they proposed this nomenclature. So this is named after them, that is Hantzsch-Widman nomenclature. Here, first coming to the type of heteroatom. In this type of heteroatom, let's study some of the important points to name these nomenclature. See, first one is type of heteroatom. Okay, in this type of heteroatom, we should keep some of the points in our mind in order to name this one. See, for example, if we are given a compound like this, we know that here the heteroatom, that is nitrogen, is given the higher priority, and I can name it as 2, 3, 4 here. 2, 3, 4. But this is wrong method. See here, sorry, I forget to mention the double bonds here. See, here the nitrogen and These are the double bonds and this is CH3. Here I will give the numbering 1 and 2 to this substituent and 3 to this and 4 to this. Why? Because if a single heteroatom is present along with the substituent, we will assign the name according to the priority. Here the nitrogen is having the priority, so no other atoms are present, that is oxygen, sulfur, like that, no other atom is present, so we are naming this nitrogen as 1. So and the substituent is named after the nitrogen with possible lowest number possible. Okay, here see 1 2 3 4. Here the substituent is getting the numbering that is 4. That's why it is wrong. Whereas here the substituent is getting the numbering 2, so it is right. Like this. See, the position of a single heteroatom control the numbering in a monocyclic compound. The heteroatom is always assigned the position 1, and if the substituents are present or then counted around the ring in a manner so as to take the lowest possible number. Okay, the first priority is given to the heteroatom only and the next priority is given to the substituent. We should name this according to lowest possible number. Okay, and now the second very important point. How to give the numbering if two same heteroatoms are present means, see here, we know that we should give it prefixes like di, tri, etc. Let's take example and understand it very well. Now let's draw the 5-membered ring. Here it is a 5-membered ring. We know that two similar heteroatoms are present. Sorry, I forgot to write here. It is nitrogen and here it is also nitrogen. So two similar nitrogens, sorry, the two similar heteroatoms are present in this ring. So how to name that? Here we should name this nitrogen first or name this nitrogen first. So here we are getting a confusion. So we should always remember first, if similar heteroatoms present means similar heteroatoms present means we should name the numbering preferably commenced at the saturated atom, only. Then comes the unsaturated atom. Okay, first is saturated atom and then comes the unsaturated atom. I will show you how. See, here this nitrogen is present along with the double bond, so it is unsaturated nitrogen, whereas this nitrogen is not present with the nitrogen, so we should name it as 1 and this is as 2 and this is as 3. If I name it as like this 1 2 3 4, this nitrogen will get 4. So if I name like this 1 2 3, so it is the lowest possible number, so 1 2 3 here like this. Once again I will explain. If similar heteroatoms present means saturated atom is getting the priority, so it is named as 1 here. So it is a saturated heteroatom. Why? Because double bonds are not present very nearer to it, whereas for this nitrogen double bonds are present along with it. Okay, see here you can see the difference in the structure only, so it is given as 1 2 3. Okay, let's try to name it. We already know that it is, just for example, the prefixes are like this. Let's name the prefixes, that is 1 and 3 diaza. That's it. These are just the prefixes. In the type of atoms, when the substituents are present, we should name it like this with the lowest possible number, and for this also we should consider saturated or unsaturated atom is present or not. Here now we have seen for the same similar heteroatoms. What if more than one type of heteroatoms are present? That means the sulfur and nitrogen present, oxygen present, like this. What if they present means? We already seen in the replacement nomenclature, we are giving the numbering that is locant, the numbering locant. It is the numbering is locant. We should give the locant and also we should name it according to the preferences. If different prefixes are present means, see, for oxygen we will name it as oxa and for nitrogen we will name it as aza. Okay, for writing this nomenclature together, see here we know that A, E, I, O, U are the vowels. Okay, if two vowels, see at the end here is a vowel, that is A. At the end here is also a vowel, it is also A. So oxa, aza. It's totally wrong. We should remove the vowel of this first part. The first part is oxa. If oxa, so remove this and it is oxa like this. Okay. Once again I will explain you. It is if two heteroatoms, that is two type of different heteroatoms are present, it is oxa and it is aza. If these two are present means we are having vowels here, that is A. It is this, it is the first part and it is the second part. So while writing we should not write oxa aza, we should only write oxaza by eliminating the last letter of this first part. Okay, here the last letter of this first part is A, so eliminate it and write it as oxaza. Okay, this is while combining the prefixes when more than one type of heteroatoms is present. Now let's take another example to understand the next point. Here it is the sulfur, it is the nitrogen, and let's substitute here CH3. Now how to name it? Here we know that sulfur is having the priority more than this nitrogen. So 1, 2, 3, 4, 5. Here the first priority is given to heteroatoms only, then comes the substituent. If we name like this, that is totally wrong. 1, 2, 3, 4, 5. Here the third position will be the numbering of the substituent, that is totally wrong. We should name it like this, that is this sulfur is given the first priority, here is the second priority, it is third, fourth, 5 like this. Okay, we are numbering like this for this. Here let's see the naming for this. If substituent is present means, for example substituent, this is the substituent. No, here to name this, first this methyl is taken, that is 4-methyl, 4-methyl, and in the 1, 3 thiaza, thiaza. This is the naming of this one. The substituent name is named first, written first. Here the first priority is for thia and next comes aza. Here it is the first part, here is the second part. Here the first part, see here is A, so we should cancel it. So it will become thiaza. Okay. Here A vowels are present, so cancel the first part last letter, so we will get thiaza. Here the substituent is named first, that is 4-methyl. In the first position we are getting thia and in the third position we are having aza, so this will become 4-methyl 1,3-thiaza. Now for naming this IUPAC, it is very important. For this IUPAC name, first we should write the locants and next one is prefix and the next one is suffix. Here locants means numbering, whereas the prefixes means, that is thiaza, oxaza like this. These are the prefixes and the suffix is a table is there to study. Now let's study about the suffixes. What are the suffixes should be given in this Hantzsch-Widman nomenclature. Now this is a table. It is for the naming of suffixes. First the locants will come and the next one the prefix and next the suffix. Here this table is named the suffix. Based on this table only we are going to name this Hantzsch-Widman nomenclature for heterocyclic compounds. Here the second type we have studied, up to now we have studied about the type of heteroatom, and the next one is ring size. And the next one is ring size, and the third one is if it is unsaturated or saturated. That is nature of this compound. Here second one is ring size. if the 3-membered ring is present, the 3-membered ring is like this. We can't make a 2-membered ring, so it is 3-membered ring. If a nitrogen is present means, if nitrogen is present means unsaturated and saturated, and nitrogen is absent means also unsaturated and saturated. See, let's study this off of the table now. See, for the 3-membered ring, if the nitrogen is present and if the nitrogen is present and it is also unsaturated, that means it contains double bonds or triple bonds, it is called as irene. Okay, it is, if nitrogen is present, if it is saturated, it is called as pyridine. And for the 4-membered ring, it is called, if the nitrogen is present with unsaturated compound, it is ETE, that is 8. If saturated compound is present along with the nitrogen, we will call it as etidine. Okay. Next one is OLE. If unsaturated is present with the nitrogen, that is called as OLE, and for the saturated compound, it is called as holidine. Okay, these are very, very, very important. See, unsaturated compound with the nitrogen present means this column will include only nitrogen presenting compounds. If it is very important in the heterocyclic compounds to see whether the nitrogen is present or not. The nomenclature totally depends upon the presence of nitrogen and absence of nitrogen. Here, in the nitrogen is present, it is unsaturated. For the 6-membered ring, for the 5-membered ring, it is ole and olidine, and for the 6-membered ring, it is called as INE, in, and for the saturated, it is perhydroin. That means we should name this perhydro and name this hin. That is, perhydro is common. See, here you can see perhydro is common, epine. For this also perhydro is common and osine. For this also perhydro is common and onine. And for this also acine, that is perhydro is common and acine. Okay, acine, that is perhydro is common. For this also acine is added. From the 7-membered ring, we should name it as perhydro. Okay. For the 6-membered ring, it is INE, perhydroin, and for the 7-membered ring, it is epine. It is perhydroepine. For the 8-membered ring, it is called as osine. It is called as perhydroosine. And for the 9-membered ring, it is called as onine. It is called as perhydroonine. And for the 10-membered ring, it is called as acine. It is called perhydroacine. That is, in the 7-membered ring, if unsaturated is present with the nitrogen is present, and unsaturated, it is epine. Saturated, perhydroepine. Unsaturated, nitrogen is present, osine. Saturated, perhydroosine. And unsaturated nitrogen is present, it is called as onine. And for the saturated compounds, it is called as perhydroonine. And for the nitrogen presenting compounds in the unsaturated state, it is acine, and saturated, it is perhydroacine. Okay. Now for the nitrogen absent compounds. Now up to this we have studied about the nitrogen present compounds. If the nitrogen is absent, how we should name the unsaturated and saturated compounds? That is very easy. Now let's learn about it. This table is very, very important. If you learn this table only, we can name the heterocyclic compounds. Now, if the nitrogen is absent, for the unsaturated, we will call it as irine. For the saturated, we will call it as irene. And for the unsaturated, if the nitrogen is absent, etane, ole, olane, in, ane, epine, epine, osine, osane, onine, onine, acine, acane. Okay. For the 3-membered ring, for the unsaturated compound, it is irine. For the same 3-membered ring, we will call it, for the saturated, we will call it as irene. And for the 4-membered ring, for the unsaturated nitrogen absent compounds, we will call it as ETE. For the saturated compounds, we will call it as etane. For the 5-membered ring, we will call it as ole. For the unsaturated nitrogen absent compounds, if the saturated is present, means olane. Okay. For the 6-membered ring, in, and for the saturated, ane. and for the 7th membered ring epene and saturated epene. Here we are discussing about the nitrogen absent compounds. For the 8-membered ring it is called as ocene, and for the saturated it is called as ocane, and for the 9-membered ring it is called as onine, onane, and the 10-membered ring it is acene, acane. Okay, this table is very important. Just take the screenshot of this. It is very important. Now we have seen to name this Hantzsch-Widman nomenclature. First we should consider locants, next one is prefix, and next one is suffix. Locants is nothing but the numbering, and the prefixes are like thai, aza, like that, and the suffixes are those which are given in the table. For the 3-membered ring, 4-membered ring, and for the nitrogen absent and nitrogen presence, unsaturated and saturated compound, it is totally different. You should learn it very well in order to name this one. Now let's start with the nomenclature. Now let's start with this 3-membered ring. Okay, let's take the example like this. This is the example like this. Okay, we have taken the 3-membered ring, and for this we have taken this one. First we should check the type of heteroatoms, and the next one is ring size, and the third one is it is saturated or unsaturated. In the ring size only this is involved, so no need to mention it separately. First type of heteroatom we should see about the type of heteroatom, and next one is ring size. That is the table, that is the suffix. It is also the suffix. First let's check any locants are present. Here only one nitrogen is present. There are no other heteroatoms are present, so no need to name this one here. So no locants is present for this. So next what we should do, next we should take the prefixes by keeping all this in mind. By prefixes, here the prefixes are, what is the prefix here? Here the nitrogen is present, so it is aza. Okay, nitrogen is present, it is aza. And next, the next is we should see whether it is saturated or unsaturated. Here it is unsaturated, that means it is not having any double bonds, so it is saturated. Double or triple bonds are present, so it is saturated. First we should see about the prefixes, and next whether it is saturated or unsaturated. And next let's check out the suffix now. Suffix is checked by this table. So see here, consider this table as we have studied already. Here the nitrogen is present, yes or no? Here the nitrogen is present, yes. And next, whether it is unsaturated or saturated, it is saturated. It is not having any double or triple bond, so it is heteridine. Okay, the suffix here is heteridine. The suffix is heteridine. Okay. Now combine this locants, prefix and suffix. Okay, here locants are not present, so prefix and suffix should be named here. Now the prefix is aza. Okay, and the suffix is, what is suffix? That is heteridine. Combine these two. If vowels are present means we should eliminate them, that is drop the last letter of the first part. Okay, let's combine these two. It is A, E, I, O, U. Here I is present, here is A is present. It is a suffix and it is prefix. In the prefix also, if we get vowels means we should drop the last letter of the first part. In the suffix and prefixes, in between the suffix and prefix also, we should drop the last letter of the first word. So see here. Now aza iridine, like this, aza iridine. Now we should cancel this one, that is here the first part is this one, so last letter is A, so aziridine. Okay, the name will become like, that is aziridine. combine these to aziridine. This is the naming for the 3-membered ring. We should check whether the nitrogen is present or the compound is saturated or unsaturated. Now let's take the example of 4-membered ring. Now 4-membered ring, NH, NH, and it is 1, 2, 3 and 4. Here the compound is having nitrogen, so it is aza. The number is given according to the lower priority. It is 1, 2, 3, 4. So we can name it as 1, 2, 3, 4 or 1, 2, 3, 4. Why? Because there are no double bonds. It is fully saturated. So 1, 2, 3, 4. Here 1, 2, 3, 4. Here 2 nitrogens are present. So it is diaza. Now locants, that is to name this locants is we are getting 1 and 3. That is 1, 3. 1, 3 diaza is the locants plus prefix. Now we should look to the suffix. Suffix is seen by the table. The other important point here is it is fully saturated. For the 4-membered ring, nitrogen is present, N is also nitrogen is present, and it is fully saturated. What is the name of this? See here, it is a 4-membered ring. It is fully saturated, so it is etidine. So it is here. See, 4-membered ring, it is saturated, so it is etidine. That is etidine. Now combine these locants, prefix and suffix. We will get 1, 3 diaza etidine. Now this is the first part, that is locants plus prefix is the first part, and this is etidine is the second part. See, here last letter of the first part is A. These two are the vowels. So we should drop one of the vowel, that we should only drop the last letter of the first part. So it will become 1, 3 diazitidine, like this. 1, 3 diazitidine. This is for the 4-membered ring. Let me explain once again. This is 4-membered ring and the nitrogens are present, that are 2 nitrogens are present. So we will use di for the 2. So 1 nitrogen is present at the first position and the second nitrogen is present at the third position. So we will name it as 1, 3 diaza. Locants plus prefix is 1, 3 diaza. Next, the suffix is seen from the table. While considering the table, we will get etidine as a suffix. So combining these two, we will get 1, 3 diaza etidine. While cancelling last letter of the first part of the word, we will get 1, 3 diazitidine. This is for the 4-membered ring. Now coming to the 5-membered ring, IUPAC nomenclature, that is Hantzsch-Widman, by applying Hantzsch-Widman's rules. Now for this, here the ring consisting of different heteroatoms, we have numbered according to their preferences. Here the oxygen is having higher priority, so it is given the lowest possible number. So it is 1, 2, 3, 4, 5, like this it is given the numbering. We already know that how to give the numbering for these. We have already mentioned about the priority of this is atoms also. Now coming to this, here the ring contains oxygen. So the prefix oxa is used, and there are 2 nitrogens are present, so aza. So it will become diaza. These are the prefixes. Before this, we should mention locants also and the prefix plus suffix. The numbering is given like this. For this, oxygen is present at the first position, so 1 oxa and In the second and fifth position, aza group is present. So, di-aza. This is the prefix. Now, coming to the suffix. We already know that to name it, we need locants plus prefix plus suffix. Now, we have completed these locants and prefixes. Now, we should see about the suffix. Here it is a 5-membered ring. It is a 5-membered ring. 1, 2, 3, 4, 5, and it is unsaturated. That means it is consisting of double and triple bonds. So it is unsaturated. It is fully unsaturated. And nitrogen is also present. Nitrogen is present. According to this, we should see the table and we should name it. See, consider this table here. It is unsaturated. It is having 5-membered ring. And nitrogen is present. For this ol, that is OLE is the suffix to be used. That is OLE is the suffix. Suffix is equals to OLE. Now we should combine all these things. In the prefix we are getting oxa and di-aza. So no need to cancel the last letter of the first part. Here it is di and it is a. So D is not a vowel. So there is no need to cancel the last letter of the first word. Now the suffix is OLE. We should combine this locants, prefix and suffix. Now locants plus prefix is equals to 1 oxa and 2, 5 di-aza plus OLE. These two are the vowels. That is, it is A and it is O. So we should cancel the last letter of the first part. It is the first part and it is the last letter of the first part. So by naming this, we will get 1 oxa, 2, 5 diazole. This is the name of this compound. This is for the 5-membered ring. Now let's study about the 6-membered ring. Now let's take the example for the 6-membered ring. Now let's take this compound as example. Here is NH. One of the carbon is replaced by the nitrogen. Now coming to this nomenclature here. Here it is the first point is here the 6-membered ring. 6-membered ring. It is a 6-membered ring. Next, whether it is a saturated or unsaturated means it is fully saturated. It is fully saturated. That means it is not having any of the double or triple bonds. Now, here the heteroatom is nitrogen. According to this only, the absence or presence of nitrogen will only decide the name of these heteroatoms nomenclature. Now coming to this, it is fully saturated, 6-membered ring is present and nitrogen is also present along with this. Nitrogen is called as aza in this. Now let's see the table here. For the 6-membered and for saturated thing, it is 6-membered ring and it is also saturated. It is per hydroine. That is per hydroine. But we should name it as per hydro first and the heteroatom which is present is second, and we should add the ine for this. First, per hydro is common for the 6-membered ring here. For the saturated, if the nitrogen is present, per hydro we should write as per hydro. Okay, next ine. Before this per hydro and ine we should write aza. But we know that already we should cancel this last letter of the first part. So it will become like per hydrozyne. It is per hydrozyne. This compound is named as per hydrozyne. This is for the 6-membered ring. This is the exact order of priority for the atoms, heteroatoms. First comes the oxygen, next comes sulfur, next selenium, next comes N, next comes P, next is carbon, silicon, boron. This is the priority order. Earlier I have mentioned the priority order, but it is for some more atoms also. First comes oxygen, next S, Se, N, P, carbon, silicon and boron. It is having the highest priority, whereas this is having the lowest priority. Now let's see example for branch heterocyclic compound. For example, let's take this compound. Here is a nitrogen. This is sulfur and these are the double bonds. And here is a substituent, that is CH3. If substituent is present means how should we name this heterocyclic compound? The first priority is given for the sulfur and second, third, 4, 5. Okay. Now for this, it is unsaturated. That means it consists of double or triple bonds. It is unsaturated and it is 5-membered ring. Whether nitrogen is present means yes, nitrogen is present in this compound. So nitrogen is present. For this, if we consider this table for the 5-membered ring, for an unsaturated compound, that is fully for the 5-membered ring, unsaturated and also nitrogen is present, we should take the suffix, that is OLE. Suffix is OLE. And the locants plus prefix, or here no need to mention. Yes, there is a need to mention. Why? Because there are 2 heteroatoms. Here in the first position here is a sulfur and in the third position here is a nitrogen. We should name it as 1, 3 thiaza. Why? Because it is thia, that is thia, it is aza. We should cancel this, we will get thiaza. It is 1, 3 thiaza as the locants plus prefix. For the suffix, we should add ol, that is OLE. Here is also 2 ols are present, so first part is cancelled here. So first part, last letter is cancelled here, so it will become 1, 3 thiazole. Now we should name the substituent in front of it. I have already mentioned that we should mention the name of the substituent in front of this. So it will become, in the 4th position we are having methyl, so it will become 4-methyl 1,3-thiazole. It is the name of this branched heterocyclic compound. If substituent is present means we should name it first. This is about the naming of this heterocyclic compounds if they are having any substituents. This complete video explains about the nomenclature of these heterocyclic compounds, that we have studied about the common nomenclature and replacement nomenclature and also Hantzsch-Widman nomenclature. So far we have studied about the monocyclic compounds only, nomenclature for the monocyclic compounds only. In the upcoming videos we will study about polycyclic compounds nomenclature also. Thank you for watching. Please subscribe to our channel.